Alright, so today I'm going to be explaining siphoning. However, it is going to be different. I'm not just going to use the whiteboard. I'm going to be using this. And this is a siphon. Not a very fancy one, but nevertheless, it's a siphon. Now, I'm going to explain that when you have water in a reservoir, in this case, the cup, why it will go up, but then, fall down, like this, thus draining the cup. Now, this works on a principle of pressure. Say we have water in here that then falls out, or we have air in there that is then sucked out. Either way, molecules are being pulled from it, whether it is water falling or air being sucked out. Now, since water molecules are being pulled from it, that means less molecules, which means lower pressure. And what happens when there's lower pressure is it is equalized. This is a natural reaction and it will happen automatically. So to equalize the pressure, stuff goes into this end. Since it is submerged in water, the only thing that can go in there is water, which will go up and then down and continue falling out. Now, since it falls out, more water will have to be pulled up to continually equalize the pressure. So that is how that works. For a siphon to work, the exit end of the siphon has to be below the entrance end of the siphon, which, as you can tell, we clearly do not have here. And it does not work. You cannot siphon water upwards. Now, you might be thinking, well, how do we know that he did the same thing he did the first time? He might have just had a straw, like an empty straw filled with air instead of the one filled with water, which is what I used the previous time. Well, to prove that I'm not just doing some sort of trickery, I'm going to now explain the concept. Now, what happened here is I had water throughout this, but since this end is higher, the water was all just sucked back up into the glass. Now, the reason it didn't work this time, but almost drained the glass the first time, is potential energy. Now, potential energy is the energy an object has when it is not in the center of another object's mass. The more common use of this, and the one we'll be using today, is whenever something is above the ground. So, say you put a book on a table, that has potential energy because it has the potential to fall, and falling is a form of energy. Now, for water to go up, it gains potential energy. We'll say it gains 1 unit for it to go up this. Now, for it to go down this, and this is about, let's see, twice as long, close to twice as long, we'll say it's twice as long, it will then go down, and it will lose 2 units, or gain negative 2 units. Now, adding those together, we get negative 1 units of energy, which is a net loss of energy, which is the natural reaction for everything, so it will continue to work. Now, what we had in the other way is this was the exit, and this was the entrance. It would have had to gain 2 units of energy, and lose 1 unit of energy, which would be ultimately gaining a unit of energy, which is not a natural reaction, and thus would not happen. Now, I'd like to point out that naturally something doesn't just gain energy, as I just said. So, when you stick a straw in the cup, as I just did, water won't just start flowing up and then flowing down, because ultimately it'll lose energy. It has to first overcome the positive energy here. So, to overcome that, I put water in here, which would then drain out with negative 2 units of potential energy, and more water would fill up, which is 1 unit, and as I already showed you, that was negative, so it would continue to happen. Another necessity of the siphon is there can't be air in it above the water line. If there is, it'll stop working. Now, for this, I've cut a hole in the top of the straw, and I'm covering it with my finger, because I can't tape it very well. And you see, it still works. However, if I move this finger, it stops. Now, to explain this, say we have the siphon running, and it is draining water. But then we cut a hole in the top, right here, and then air gets in. Air, being lighter than water, requires less energy to move, as explained with inertia. So it is sucked in easier than water, and the water coming up here just falls back into the glass, and the water here just falls down to the ground, and this area then fills up with air. Now, since air is the same weight as the air outside, kind of know that, it won't continue to flow down. Not that you'd be able to see it anyways, it just stays in there, which isn't as interesting. Yeah, hope you guys enjoyed it. If you want to recreate it, you'll need a cup, a bendy straw, some water, and that's about it. If you're doing it inside, you'll want a bin, so the floor doesn't get all wet. But if you're doing it outside, you don't need to worry about it, because it's outside. However, if you're recording, the lighting is usually better inside. But yeah, as I said, hope you guys enjoyed it, hope you learned something, and see ya!